Another draft physics video presentation. Just two comments, disappointingly stupid ones, and maybe that's all they'll be. I don't know. Whole project's getting so discouraging because it just seems obvious. People want to believe nonsense. They want, the fancy story, the made-up story. They want the fable. They don't want the reality. You and I don't know about that, think of light and other forces, good, called it a force, as something that radically spreads in straight lines. Well, mostly. Yeah, I mean, there's the spherical thing is part of what gravity causes, so most objects will be spherical, and so it'll be even and all that kind of stuff. Yet I heard you occasionally speak of wavelengths. Can you explain what you are referring to? So he doesn't understand the difference between which way something's moving and how many of those things are moving that way. The distance between bits of stuff moving in a direction. So again, we're back to language difficulties in the sense that they've used this word photon like electron and like proton. There's always something. And, it makes it sound like it's a one thing. That a photon, like an electron, is a one thing. There's just a photon. But, they've so screwed up what electrons are now. Electrons aren't things anymore. They've been quantized into something that doesn't have a location, because it has a velocity, it has a frequency. So I haven't been the one who's confused the language. Sorry, it's not my fault. Physics never cared to fix any of these misconceptions. But the wavelength, okay, so you could argue that an electron could have a wavelength in the sense that it could be the distance or the size of the width of the electron, but of course science doesn't consider that. It's certainly not the wavelength of an electron. When they talk about an electron having a wavelength, they talk about it based on its velocity. So the faster it's going, the higher its frequency, even though it doesn't have a frequency or a wavelength. So that's their made-up bullshit. I can only account for it by saying that's all just made-up bullshit. That's de Broglie bullshit. It has nothing to do with reality. Because in one circumstance, frequency is important, like when you're trying to tip something over. It's really important, if you're trying to tip it by throwing baseballs at it. It's really important that you throw the baseballs on resonance. That means on the resonant frequency of what you're trying to tip. So if it's, if it's rocking this way or it's rocking this way, you have to throw your impact so it's constructively added rather than destructively subtracted from the motion. You want to add energy to the motion. You don't want to take energy out of the motion. And so, because there exists that phenomenon, sometimes frequency matters and can make something seem more powerful. So somebody smart can have tennis balls and throw them, at, let's think of something big, an elephant. And if he does it just right, he can knock the elephant over with tennis balls. And then some idiot with cannonballs, throws him at the elephant, and he won't be able to knock him down in a million years. He'll just hit the elephant, push in, bounce off, push in, bounce off. Because he's not recognizing that there's this concept of resonance. And the concept is that you can add energy to a system. And so the smart person tips the elephant by causing a little bit of extra motion in just one direction, making the pendulum swing more dramatically. And because that exists, physicists, idiots, decided to say frequency is energy. Frequency is velocity. It's not. It's the same thing as velocity. It's the same thing as momentum. It's not. It's a different concept altogether. And it has nothing to do with anything if the system doesn't have any resonance. So if you can't find the resonant frequency, if you can't find a tipping motion, if you can't tip it, or if it's untippable, it's not going to matter frequency. And all it's going to matter is, in terms of energy, is how much energy you have to use to throw cannonballs versus how much energy you have to use to throw tennis balls. The only thing that's going to matter is the momentum you hit it with. And that's the only part of the equation that's going to be relevant. And, it's back to the normal understanding of momentum. So it's just their broken conceptual verbiage. So a photon, as I've repeatedly stated, is not made of one ton. Alright, twan, as the jokers would say. It's not made of one twan. Okay, it's made of more than one quanta of energy. And they're at a specific distance when they hit something. Bang, bang, bang. Quanta. And that's the frequency. Now, like say a radio wave, right? Radio is at a frequency. Now, technically, if we could create a oscillator that could oscillate at the nanometer scale, that is, at the same frequency that light occurs, you could technically create light coming out of a radio antenna. So if we could oscillate the antenna at a high enough frequency, we could make it produce visible photons, visible light, because the quanta would be at the right spacing. And the antenna is basically, what's the antenna doing? The antenna is vibrating from a frequency, but the vibration is really an expansion, contraction. And what it's doing is it's charging the atoms, and by charging the atoms, it's moving the electrons. The electrons move this way, then they move this way, then they move this way, and they move this way. And when they move this way, they produce a quanta of energy out. So this little quanta flies off the antenna. And then when it vibrates again, another quanta flies off the antenna. And when it vibrates again, another quanta, another piece of energy, a bit, flies off. And because they're at a frequency, we can receive them at another device because they hit at a regular frequency, which allows electrons to move at those frequencies. And we can interpret the movement of the electrons as electricity. So there's no inconsistency, because understanding that force moves in straight lines and is emitted proportionally from something like an electron, and understanding that the force bits always move in straight lines, and the fact that there can be wavelengths, which is there's force and then no force, and then force and then no force. That is bit, then no bit, then a bit, then no bit. And as I pointed out, when electrons decelerate, to decelerate they have to be making force exchanges. And so depending on what field of energy you're pushing against them, that is how many rowers in the water in front of them, will dictate how often they make exchanges. So the more, if I'm in a swimming pool and there's 10 people in front of me and I'm going to plow through them, I'm going to have these 10 interactions. And but if I put 20, then I'm going to have the interaction is going to happen at a higher frequency. More often I'm going to hit somebody and have an interaction. And the interactions to an electron mean a change in their direction. So if they're going fast, they're going to slow down and then switch direction. and even if they're going slow, that's going to happen. But they're going to do it at the rate at which they're hitting in the field. So the more stuff in the field coming at them, the more swimmers in their way, the more rowers to come in their boat and make exchanges, the more often they're going to throw a swimmer back into the pool. So they take one on and then they throw one back in. And so that's going to dictate how often they're throwing a swimmer out is going to be dictated by how fast they're plowing into a field and how much stuff is in the field. So that's why atoms can create X-rays, or they can create infrared radiation. From very different frequencies, insanely different, really, a lot different. And it just has to do with how much energy you're throwing back and forth. How close the electrons are dictates how fast the little bit is moving back and forth, in the sense of how many interactions are happening. So there's a lot more interactions when the two things are close. I've said this with ping pong balls and a ping pong. You can just imagine 2 paddles and a ball that keeps bouncing. The closer I go, it goes ding 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 ding, ding. The further away, it's bong 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 bong. Right? That's the frequency. So the closer two electrons are, the more likely they are to create X-rays. Is they're moving into, all the time, fields that have more swimmers in them, more bounces, more interactions, because they're closer. So I should have given the analogy of you're in a swimming pool of a certain size with 10 people, and I make the swimming pool twice as big. It's going to, cut in 1/4 how many interactions I'm going to have. Alright, so I think that's well enough disposed of. So Superior Mind said, distance between photons, kind of like bullets emitted at a frequency. Well, again, you have to explain first that photons aren't electrons. They're not a solid object themselves. Electrons are a boat. And swimmers are the parts that make up a photon. A group of swimmers in a row at the same distance, moving in the same direction, that's a photon. Along a trajectory, not actually a wave in something. Yes, there's no waving. This wave is just not a real, it's not an elemental function. It's something you see. Okay, it's not something after a whole bunch of other interactions have taken place. It's not elemental. Alright, so just get rid of this whole thread, I think, because it's just... like I said, if you don't know the difference between the direction something's moving and frequency, I mean, I really, you're just not, you got to know at least some high school physics here. I mean, you really don't have much chance of understanding why they're wrong and why I'm right. Frankly, if you don't know the difference between a vector of direction and momentum and velocity and periodicity. Anyway, Travis Cook, the uncertainty problem isn't a measurement problem. Says you. I mean, it's just this stupid statement. It's like saying, all right, so you have two competing theories, the God theory and evolution, and somebody shows them to you. Now, one is just completely based on a simple principle, requires nothing fancy at all, and the other one is this elaborate nonsense that is idiotic. One's easily disproven because it is mechanical and physical, so it's easy to find some sort of evidence that's outside the realm of what evolution could do, and the other one, they can just make up any catch-22 they want. God made it broken on purpose. God put dinosaur bones in the ground just to fuck with our heads, to see if we would lose our faith easily. You can just make up any crap. Alright, so there's certainly a measurement problem. Sean Carroll concedes it's a huge problem. But anyway, it's not that we don't have the ability to measure something as small as particles. It's a fact, okay? It's not the reason not to believe your nonsense, okay? The reason not to believe your nonsense, there's a ton of those. It's just a fact that we can't measure it. All right? So again, this is just such a lie to pretend, oh, the problem isn't our measurement because we can measure it. No, we can't measure it. That's a truth. And so it's invisible. And you're going to tell me now what the invisible thing is because you have some evidence of it, even though you never measured it. That's what's happening here. The truth is we can't measure it. We can't see it. And now you're going to tell me, well, anybody with any eyes can see that it must be Heisenberging. What? I can't see it, and you're going to tell me that that's what it's doing. Oh, fuck you. All right. The ability to measure something is, it is, the particles aren't really particles. Again, and you say that with what authority? So you say there's a God, I say, no, I can explain the existence of all the phenomenon by just identifying these things as things moving through space with a certain vector, and their direction is changed when they interact with matter. That's it. It's not at all complicated. You're telling me I have to believe that the default thing I should believe is this nonsense, even though there's absolutely no evidence for the nonsense. No evidence that we need Heisenberg at all. Anyway, they're waves. Says you again. Prove it. Waves in what? Waves moving in a straight line, dead straight lines. You know, what kind of wave is that? It's not any kind of wave that anybody else has ever seen. So what do you mean? A wave in what? A wave how? How exactly is it like a wave when it lands as the tiniest bit of momentum possible in a location? Just bullshit, sorry. You have no evidence and you're saying you must believe in my God. Every particle is just an energetic oscillation in a field. A field of what? An energetic oscillation. What the fuck does that even mean? I mean, you can say, look, the ether is made of bubbles, and the bubbles expand and contract, okay? Well, then I'll argue you still can't make straight line geometry unless your bubbles can somehow know to move in to rearrange themselves. The checkerboard creates a geographic geometry problem. You end up with diagonals that are longer, the distance, than the horizontal and the vertical. And you can't make a straight line, except, if you obey the geometry. The geometry only works in two vectors, however you want to put it. It doesn't work on the funny angles. But again, there's just no evidence provided, nothing. No reason for me to believe any of this. And this idiot's talking as if I don't already know the story you're telling. Yes, of course I know your story. I know your story is you're saying the things we can't see, the invisible things, have special properties. And I'm supposed to believe they have these special properties. Why? Because you can't rationally interpret experiments. That's why. Because you think like there's a slit of matter and you're going to shoot light right next to it, that somehow the matter doesn't influence the photon. No, the photon's a wacky-ton. And it didn't like being compressed. It didn't like being measured. So it's resisting the measurement by going wacky. No, it's just doing what all photons do when they refract through a substance, when they bend. And they don't need any magical theory. All you need to understand is they have to hit electrons. Photons go in straight lines. They go in a straight line from point A to point B, unless there's a point C in the way that they hit an electron. They only change their direction when they hit an electron. I mean, this is just so fucking stupid. But it just points out how hopeless it is. This guy thinks the default assumption should be wacky ball. The default shouldn't be there's a reason why the photon changed its direction. There's a cause to the effect. I shouldn't believe in cause and effect. That shouldn't be my default understanding, even though every single thing that's happening around me in this bigger universe has every appearance of being cause and effect, and everything in the bigger universe is obviously, there's no wacky ball going on in there. Just big giant things. I mean, fuck you. It's just so fucking such bullshit. So, no argument made here at all. I mean, except when it's so trivial and stupid. That you're just saying, you really think I didn't know that your silly argument was, we don't think, okay, that it's invisible because it's invisible. We think it's invisible because it wants to be invisible. It's trying to be invisible, or it has invisible powers. All right, it's not invisible just because it's too far away for us to see. Right? That's what he's just telling me, right? I can't see the stupid Ferris wheel, spinning in Britain there next to the Big Bend. Big Bend? Yeah, the Big Bend. I can't see it. And so, but I should assume you're saying, I can't see it because it's hopping all over the place. It doesn't know where it is. That's why I can't see it. No, I can't see it because I can't see it. Alright? I can't see it physically. It's impossible for me to see it. That's why I can't see it. It's still sitting right there next to Big Bend. Okay? It's not hopping anywhere, you fuckhead. And you're saying to me, I have absolutely no evidence to provide you, but you should believe that, nah, the Ferris wheel really isn't right there. No, it's hopping all over the universe. It's in Venus right now. No, it just flew to Saturn. It's bouncing all over the fucking universe. Yeah, fuck you. This is like, like I said, this is worse than talking to 5-year-olds. Because they don't have some preconceived, perverse horniness to turn everything into shit. Ugh. There. That's it for the comments. Oh, I could play some more of the stupid LIGO crap. Let's just go with this signal thing, okay? But this is... So they're showing this. Now maybe all these numbers don't mean anything. Okay, maybe this is all just horseshit. But clearly the frequency is an indication of the rotation speed. Okay, so the up and down motion is the speed of the rotation. And the amplitude, okay, the height, has something to do with the strength of the signal. That is how much change they're receiving in the signal. Now, this isn't dramatic here. So they talk about this merger event, and there's 3 solar masses released and all this crap, right? Well, the obvious question is, if the solar masses are released here at this point, and it's this insane amount of energy, right? I mean, the whole universe, the energy the whole universe is producing for that little moment of time. Why isn't the signal huge by comparison? It's not even double this amplitude. So the logical point to make is that, well, it has to be converting solar masses here, doesn't it? To be creating this signal that's loud enough for you to hear. Because by Einstein's physics, you couldn't hear this unless you're ripping solar masses. You're converting them into the pure energy of bent space-time. Again, Einstein wrote no such formula. Energy equals bent space-time. There's no such formula. You can't logically make any sense out of what they overtly say. So he's going to overtly tell me that for just 1/10 of a second, all of this energy was converted. Well, this signal is longer than 1/10 of a second. So how did you receive this thing that's half the amplitude of the 3 solar mass moment? This is half the amplitude of the 3 solar mass moment. How does that make any sense? That's right, it doesn't make any sense. But there's no point in going. You people all just you want to believe. The good news is that the comments on this video actually weren't very good. I mean, there's a lot of people saying, oh yeah, sure. Alright, so one guy says, thank you, Kip, for this very interesting lecture. Yeah, he's a friend, you can call him Kip. Kip is just such a fucking, what a stupid name. Anyway, ends up being the most of his talk. Okay, history, brief. Well, obviously it wasn't brief, but anyway. Honestly, the Galileo comparison at the end made me emotional because of just how true it is. Gravitational wave astronomy is incredible, and in my opinion, it's going to be the key to understanding a lot of the most difficult problems in physics. Just amazing that they think this is physics. At the very least, it's going to allow us to gain deeper understanding and confirm and disprove a number of hypotheses that would have... No, you're just confirming your own hypothesis. You've now proven things by saying them, and that's all you've done. By finding gravitational waves, we've proven bent space, and we've proven black holes exist, and we've proven this, and we've proven that. So that you're just using, this is so circular. You're using your own statements, your own testimony. It's like you're the lawyer, and you put yourself on the stand. You say, I think he's innocent. And now you say, without in your closing arguments, but didn't you hear that guy say he was innocent? So shit, he's innocent, right? Because the guy said so. Before I watched this, I was really convinced of the importance and beauty. See, I mean, this is just such baby talk. Oh, jeez. The absurdity of a black hole. The astrophysicists are obsessed with the concept of collapse into a singularity with zero volume, infinite density. Well, the whole problem of this whole thing is, again, is this mathematical approach doesn't concede to realities too often. But most people who do equations, like even Maxwell, they put a stop in somewhere to prevent the math from going loopy. Okay, and this math just doesn't have enough stops in it to prevent loopy. I mean, conceptually, once they accepted that they can use this stupid bent geodesic as a model, they just said, well, we don't have to put any absolutes on how much how deep we dig the well. So once they say we're going to use a well analogy, they create the well analogy in an atmosphere where there's absolutely no limitation on how deep they dig wells. So they can make an infinite well. And it just doesn't make logically any sense, because there's no infinite size. The universe has an infinite size. You can't do that. No explanation how physics can occur in a place and point with zero volume. Yes, exactly. I mean, it's just so stupid. This comes close to my sponge theory of creation, so it's pretty funny. Lost the response due to wrong key press combo. Daughter says I should write a book. Yeah, well, I think she meant you should bang your head with a book or something. But anyway, I would like to understand how it's possible the propagation of so much low frequency waves through space. So this is another guy who doesn't seem to understand the difference between the stuff and the frequency. What's it matter what frequency it is? The frequency of asteroids, this frequency of comets. I mean, I don't know. Why those objects are called black holes? I mean, it would be like Team Black Hole Star movie. It is, I mean, frequencies do matter. The high and low can matter because of when you're interacting with matter. So with like radio, we have this assumptions about, the strength of a signal is based on its frequency and all this stuff, but that really just has to do with how reflective the higher and lower frequencies are. So they have different advantages and disadvantages in traveling distances based on the fact that they survive better or worse in terms of transmission. And that's really all it has to do with. So they can get reflected or absorbed. So the low frequencies are more likely to be absorbed. The higher frequencies are less likely to be absorbed by mediums. That kind of thing. So they'll travel through, the high frequencies will travel through a medium better. The low frequencies will reflect off a cloud better. Some kind of crap like that. Nonsense. Gravity waves more like it. Gravy waves. Yeah, so it's the gravy wave comment. Let's see. Gravitation is one of those things that still only can provide equations. Again, yes. No, you can model it, called mock gravity. It seems to have it all figured out, but still cannot make gravity. Defy gravity, created gravity, and some of the real problems can be the facts, like the first, our planet. What is this? Did it come from the outer area, or was it caught up in Jupiter's orbit and rolled smooth? It didn't get rolled smooth. Gravity makes it smooth and lost to the sun. Are we from the sun during purge? A slag like all of this is not terribly you can come up with lots of scenarios, but I mean, if you're going to bring it from the outside, then the rule is you have to make it crash into something. Now, if the sun previously had novaed and there was still a bunch of crap in that atmosphere, that could slowly condense back into the sun. So the sun novas, everything slows down because of the gravity, the big pieces, the elements. So they expand out, and they stop, and then they start contracting again. And as they contract, they can consolidate into orbitals and become planets. So there's lots of different ways you can model it that work. I don't find all that crap terribly interesting, but fine if that's what you're worried about. But it's a real problem when you're talking about black holes because of their gravity. So that's another thing. They show these images of these black holes and then they have them different sizes. The problem with different sizes is they're going to process all over the place. You know, if you have two uneven things spinning because one of them is creating, you know, it's again, you can't do the Newton thing. You can't just pretend the force is always the same. It's not the same. One thing moves more than the other thing. We move a lot more, the Earth, than the sun moves, because the sun's huge by volume and density, and not density, by mass. So only a tiny piece of the sun moves towards us, where all of us move towards the sun. Huge difference in which thing is going to get to be able to pull into an orbit. So if two black holes of a different size are spinning around each other, they're going to fly all over the fucking place, because their orbits can't in any way be perfect ellipses and all that crap. So light travels slower than gravitational waves. That's at 40 minutes. I don't know if I want to go all the way. Let's see, this might open in the right. It might open it at 40 minutes. Yeah, it did. Cool.
But the signal that came in on August 14 of last year, we identified its location with an amazingly small error bar.
Oh, okay, so this is just where he's talking about the fact that after the fact, so they're saying that the burst of regular electromagnetic energy happens after the black hole merges. So somehow the after effect of the black hole merging is the one creating this burst of gamma rays, or whatever the fuck they saw. Which does sound on its face like horseshit. So the thing looks like a kilonova, they call it. So it somehow has all of this, like, you know, it's more than just a supernova, and yet it merged. And it already did the solar mass thing to do the gravity waves. And so, yeah, it is a legitimate question. If it lost 3 solar masses to make gravity waves, how does it have energy still to burn to throw out these gamma ray emissions? Where did they come from? And why are they showing up, whatever, a minute later, or whatever the thing is? Alright. So, yeah, that is a real question. Let's see what the answers were. No. Who cares? Science is gay anyway. Well, it's becoming gay. Don't look for science videos if you don't understand it. So this is more bullshit, like you do understand it. Oh, I'm sure you do. No, I'm sure you don't. Adam Pickering. Can space travel faster than the speed of light? Question mark. I don't know. They both travel at the same speed. But that doesn't mean anything. Apparently. It doesn't mean anything. Completely different physical mechanisms. And it doesn't mean anything that they move exactly the same speed. It's like a coincidence or something. Who cares? It's not interesting data. No. We shouldn't assume there's some... we should be unifying those things. No. Let's keep them separate, and stupidly so. Alright, do gravitational waves carry energy on top of space-time that makes the waves? Or is the energy inside space-time's fabric propagating out around the universe? So again, if you give a shit of what Einstein would say, no, there's only one way you manipulate space-time. Okay, that's by having mass. You have mass, you cause a convergence, okay, in space-time. That is, you pull on it. And that's what you're doing. You're pulling on the space-time as everybody else will see it. So you're contracting. In a sense, you're contracting. You're taking space and you're pulling it in. to you from all directions. And so you're creating a contraction, and that contraction moves through space at the speed of light. So you're pulling on the rope, and the other end of the rope takes time because it's far, far away, but eventually the other end of the rope moves. That's all Einstein would tell you that gravity is. That's all he'd say bent space is. That's all he'd say bent space-time is. You pulled on a rope. Okay. I want to know if there is energy riding with the waves or if the energy transferred into space-time's fabric. So again, how does it make any sense? It's movement. Period. And movements associate with the word called energy, because you have to have energy to move something. Now, again, once you've accepted this stupid notion that gravity is caused by a geodesic, some kind of geometry bending, well, then you've broken the concept of energy. You don't need it anymore, as long as you can make that a closed system. So as long as you understand that it's going to take as much, the energy you use to fall into gravity will be exactly the energy you'll give back to get out of gravity. So it's thermodynamically conservative. But it's not conservative if you open the system to the whole universe. Alright. Because there's no causal effect for the initial movement. There's no identification of the first cause. Alright, the energy is the waves themselves, isn't it? I don't want to sound fictitious in that reply. The energy lives in the tidal deformation and vortex twisting of space-time itself. So now we're back to vortexes. It wouldn't be a wave if it did not have energy to operate as fuel. This guy called Albert Einstein. Shit. I hate people. Anyway, that wasn't worth reading. Alright, so we'll just say fuck this too. Anyway. So, there's obviously just no one capable of having these conversations, sadly. There's just nobody doing it. Nobody interested enough to debate these fundamental issues. And that sucks. That's what we're stuck with. Alright, the Science League guy takes no criticisms, explains none of his bullshit crap. It's just a religious kook. I don't know, like I said, I just started unsub from Piro. He doesn't make any videos about anything that I could give a shit about. And what else is there? How special to... Oh, look, he's doing such a cliche dork video. Where were you on 9/11? Oh, that's just so interesting. Fuck. I was watching the news. That's where I was. I was watching buildings fall down in New York. It's pretty bizarre, I have to say. Anyway, until the next time and such. Amazed how little real impact it had on humanity. We've changed nothing. We realized nothing. Oh, maybe violence isn't going to work in the future. No, nobody came to any rational understanding of the consequences. Like I said, the real lessons that should be learned. They just went back on banging their little hate drums. Well, let's go knock some of their buildings down. That'll fix it. Stupid shits. Anyway. So, till the next time and such. Short and depressing.